Hello, my name is Matthew Stern. I'm going to go through over the 5 questions that ask for work to be shown, just in case there's any mistakes that my group members make, because we have to film this individually due to the circumstances. So here we go. I'm going to start off with number 7, and it says the average diameter of a sample of coronaviruses is 109 nanometers. With the electron microscope, convert the unit to decimeters. Okay, so what I did first is I wanted to write out the conversions on the top of the paper so I wouldn't get confused. So we start off with 109 nanometers, and then you have to multiply it by the conversion to meters, and you put the nanometers on the bottom so the units cancel. And there's 10 to the negative 9th meters and nanometers. So then you want to get it to decimeters, so you multiply it again with meters on the bottom so the units cancel out. And then 10 to the negative 1 meters is how many meters there are in a decimeter. So pretty much all this is equivalent to 109 times 10 to the negative 9th times 10 to the positive 1, because when you bring this negative 1 up, it becomes positive. So you get 109 times 10 to the negative 8th, because negative 9 plus positive 1 equals negative 8. So then you have 109 times 10 to the negative 8, but that's not in scientific notation. So we have to take the decimal point and we have to move it over to the left twice, which means we're decreasing it by 2, which means we have to increase the exponent by 2. So we end up as our final answer getting 1.09 times 10 to the negative 6th decimeters. And if you look here, that's the correct answer. These are all wrong because the exponent is not negative 6. And this is the correct one, 1.09 times 10 to the negative 6 decimeters. So now we'll go to number 8. Piece of plastic has a mass of 8.2 milligrams. Convert the unit to decagrams. So pretty much here we are for number 8. We have 8.2 milligrams times 10 to the negative 3 grams over milligrams. These units cancel. There's 10 to the negative 3 grams in 1 milligram. And then we're going to multiply that by 1 decagram over 10 to the positive 1 grams, because there's 10 to the positive 1 grams in a decagram. And then all the units cancel, and we get to here, and it says 8.2 times 10 to the negative 3 times 10 to the negative 1. And that ends up being equivalent to 8.2 times 10 to the negative 4 decagrams, because negative 3 plus negative 1 equals negative 4. And if we look here, the options, the correct one is the first one, 8.2 times 10 to the negative 4 decagrams. And these 4 are wrong because they have the wrong exponent. Okay, and now we're going to go to number 18. And number 18 says a small drop of rain has a diameter of 202 micrometers. Convert the unit to hectometers. So we're back here again. 202 micrometers times 10 to the negative 6 meters over micrometers, because that's the conversion from meters to micrometers. And then these units cancel. And then we're going to multiply that by 1 hectometer over 10 to the positive 2 meters, and then these units cancel, and that's the conversion from meters to hectometers. And then all of this becomes this, 202 times 10 to the negative 6 times 10 to the negative 2, because when you bring up the squared, it becomes negative. So this is 202 times 10 to the negative 8, because negative 6 plus negative 2 is negative 8. 202 times 10 to the negative 8th, we're going to want to put into scientific notation. So we move the decimal place 2 times to the left, which is decreasing by 2, which means we have to increase the exponent by 2. So that means it comes out to be, in scientific notation, to be 2.02 times 10 to the negative 6 hectometers. And this is the correct answer, 2.2 times 10 to the negative 6 hectometers. The rest of the ones are wrong because they have the wrong value for the exponent. And then I'm gonna go to number 19. Number 19 says a piece of foil has a mass of 3.6 times 10 to the negative 2 grams. The foil has a length of 3.00 centimeters and a width of 2.00 centimeters. The density of the foil is 1.8 grams per centimeters cubed. Calculate the thickness in centimeters. So pretty much, we start off with the formula for density equals mass over volume. They give us the density is 1.8 grams per centimeters cubes, and they give us the mass at 3.6 times 10 to the negative 2 grams. So we're going to want to solve for volume. And then we isolate for V, for volume, and we end up having 3.6 times 10 to the negative 2 grams divided by 1.8 grams per centimeters cubed, and that comes out to be 2.0 times 10 to the negative 2 centimeters cubed, because the grams cancel out. So you get 2.0 times 10 to the negative 2 centimeters cubed. Then we're going to want to do the next step, and we know the next formula is volume equals length times width times height. We just solve for the volume, which is 2.0 times 10 to the negative 2 centimeters cubed. And it's asking for thickness, which is also known as the height. And in the equation, length and width are given. So this is the equation, solving for h, for thickness, height. And it comes out to be 2.0 times 10 to the negative 2 centimeters cubed. 2 times 3 equals 6 centimeters squared times h is the height. And we're going to want to isolate the h. So we divide by 6.00 centimeters squared, and we got to do it to this side too. So 2.0 times 10 to the negative squared centimeters cubed divided by 6.00 centimeters squared, that equals 0.33 times 10 to the negative 2 centimeters, because 2 divided by 6 is 1/3, 0.33, and the exponent stays the same because there's no exponent there, so it's just negative 2. This is not in scientific notation, so we want to move the decimal over 1 to the right, which increases it by 1, which means we have to decrease the exponent by 1, which means our final answer for thickness in centimeters is 3.3 times 10 to the negative 3 centimeters. That's the correct answer. The other ones just don't have the correct value for thickness. And the last one is when the solid pellets are dropped into the cylinder, the water level increases from 30.0 milliliters to 36.0 milliliters. The pellets have a mass of 54.0 grams. Calculate the density of the material in grams per centimeters cubed. So pretty much back to here, we know the density equals mass over volume. For volume, we want to subtract 36.0 milliliters minus 30.0 milliliters. That's for the volume, kind of like displacement, and we get 6.0 milliliters. So now, and we are given that the mass is 54.0 grams. So density equals mass over volume. 54.0 grams divided by 6.0 milliliters is equivalent to 9.0 grams per centimeters cubed. 9.0 grams per centimeters cubed is the correct answer, and the other ones just do not have the correct values. Okay, thank you very much.